What's up, guys? Today we're going to look at Advent of Code Day 7. I tried this earlier and I was getting an error. I don't know if anybody else saw the 500 internal server error on this site, but we're here now. And I have to admit, in the intervening time since then, I've seen Jonathan Paulson's video. So I've seen somebody do it. I'm totally cheating. The challenge will be, can I remember it? Can I do it in my own way? Can I explain what the heck's going on? The theme for today is a terminal command prompt situation where we get commands that a person typed in and we get the results of what they saw, and then we have to sort of build a model of what's going on in this computer. The commands are only two possibilities. We have cd, which is a real thing, change directory. You can go up a level or you can go down a level. And then ls is list. It'll just show what we have, which could be files, and we don't care what the files are, we just care about the size. Or it could be other directories, and we actually don't care about that until we get there. Like when we get there, we'll get the files and their sizes, but just knowing that there is a folder doesn't really do anything for us in the moment. So then we sort of consider what it would look like and how deep it goes. The size of a folder includes all the subfolders. So like the outer layer includes everything, and some middle layer includes not only itself, but all the folders within it. In some ways that makes it annoying that we have to add things up, like a file counts for multiple folders along the way. But in other ways that makes it easier because it's sort of flattened and we don't have to only care about the end of the branch, we care about everything equally. And then the questions are going to be asking like, what are the files under a certain size or over a certain size or something like that. So right now I've loaded the input data, and it's just 1,000 lines of these commands that start with $, and the results that don't. Like I said, we can kind of ignore a lot of them, which is really nice. When they do the ls, well, that doesn't matter right now. We're going to see files soon, and we'll use them when we get them. But if there's an ls line, we don't do anything right now. If there's a dir, that means directory. That means like, hey, there is a folder. But we don't do anything now until we get there. And then we add up the files if we see any. So really the only things we care about are a size. Right now we can add it. And a command so we know where we're going. So let's just write a little bit of a structure that goes through and looks for those things, and then we'll decide what we're going to do when we see them. I've got these two lines to open it up, and so if I print lines, we're going to see the stuff we just saw, except now they are split into, quote-unquote words. They're split on the spaces. So we can say if like $1 is the first thing or a CD is the second thing or whatever. And in fact, that is what we're going to do. I'm going to say the sizes are the most important because the questions are asking us about folders of a certain size or under a certain size. So let's say the sizes are most important. We want to get that right away. I'm going to say if line, we got to do our for line and lines thing to get one at a time. And then if line 0, meaning the very first word, is a number, let's say we're going to do something with size. I don't know what yet, but we're going to do something, okay? And then we are also caring about the cd commands. And I don't know if they're being tricky here. I'm a little paranoid about like what if they use cd as a file name or something. So I'm going to check for the $sign just in case. I'm going to say if line, let's say I want to do the up a level and down a level as separate things. So I'm going to say line, the first 3 is going to be $, in quotes, and cd, and ... is the command to go up a level. That's the argument after CD. So if that's the case, we're going to do something. And then I'm going to say elif. You never know. Might matter. Otherwise, if the first two are, that needs to be double equal. If the first two are dollar and CD, then we're going to do something. And that's all we have to check. We don't care about ls because the important information will get to us soon. We don't care about dir because the important information will get to us soon, but they don't pay off until the score or the size, or until we jump around. So we'll know that, and we don't have to care about those lines specifically. Now, what are we going to do when we have this numeric thing? I don't want to have a bunch of lines in here. We're already indented 3 times. Let's put that in a separate function. I want to call that, you know, accumulate or something like that. Accumulate size. Okay. And what does that need to know? I'm not sure. It's probably going to have some parameters, but it's going to do some stuff. So accumulate size with some stuff. And then these guys are going to be simpler because they're just 1 line each. What I said earlier is that, you know, the fact that everything gets treated equally, if you're a folder in the middle, if you're a folder at the end, you're kind of all the same. And that means we don't have to truly represent this nested tree structure. We could just have one path, and the path goes forward and back, and it's going deeper and back, but it's not like remembering where it was or anything. So I'm going to take the idea from the Jonathan Paulson video, and I'm going to have a path that is just a single line that goes in and out, and it doesn't really care about keeping track. So if we're doing the dot dot, that means path.pop because we're going back a level. And if we're doing the deeper into a folder thing, then we're going to go path.append. What are we appending? We're going to append line 2, which is whatever comes after the CD, if it's not the 2 dots, if it'll be the name of a subfolder. And I think we can trust that it's going to be real. They're not going to like enter the wrong name and get an error. We would have seen something like that in the lines in the first place. So really this is it. Obviously we have to fill in the function, but that's what we do when we read the lines. Let's say what's going to happen in here. Well, the path is not keeping track of the sizes. We need another thing for that. And that's just going to be a dictionary. We're going to say like, okay, the name of this path is something based on all these weird strings we're seeing, and it can get a number, but we're going to add to it. It's got to be something that we can change, because whenever we see a folder that has a file in it, that file gets added to the size of this folder, but also all the ones, all the parents along the way. So the guys at the beginning really get added to a bunch of times as we find stuff. So we have to have like, you know, something mutable. So we're going to say like, what does this need? This is going to need path. I mean, it's a list. We can kind of treat it as global, but we're gonna mention it. And then it's going to need the size, but the size right now is still a string. So I'm going to say int line 0. Okay, so that by the time it gets to the function, it's an integer. We can add it. And when we want to say what happens inside of here, well, it's going to be, I'm going to say path name is like, we're not using the list because when we put it in a dictionary, it can't use the list as a key. It has to be something immutable. It has to be something hashable. So this is going to be a string, and it's going to be a string that's just like what you would see in a computer if you're going, you know, C slash program slash whatever, you know. So we can say slash dot join path, but we need to do this multiple times. So it's like we're going to the path of the big guy and then the slightly smaller guy and slightly smaller as we go. So this is going to have to happen multiple times. So I'm going to go for I in range and then the length of path +1 because we got to keep going. And then so now path name, there's going to be like multiple path names. So like when we're a couple levels deep, we have to add on to the big guy and then the second guy and then the third, all the way until we get where we're going. So that's something. And then we're going to do like, we're going to add it to the dictionary. And you know what? I think if I remember in that video, the guy used a default dict, but whatever, it's fine. We can just use the get method to have a default just in case. So what we want to do is say like, oh, well, if we haven't had anything yet, then it starts at 0, right? So I'm going to say sizes dot path name. Maybe I should just say size with no s, but I think I want to use size later for like a, you know, variable in a loop or something. Sizes path name equals, this is where we're going to do the default thing where it's like get path name, if you don't find it, 0 plus size. And we forgot to list those parameters. So it takes a path and a size. Okay. And I think that's all we need. Let me try to print something. Let's print, or let's say like for path and size in sizes, print path and size. So this will be like path, a number, path, a number. Or it'll be an error because I messed up, who knows. Well, I forgot the colon. That's easy to fix. Not enough values to unpack. Got, oh, I was supposed to say dot items, of course, when you're going through both parts of the dictionary. Ah, that's what I had envisioned. Okay, so this is like the path and then the size, which remember is the accumulated, the single file doesn't just add its number once, it adds it to all the guys along the way, or at least I think it is. So now we got to say, what are we actually supposed to find? What are they actually asking us? That is, what is the sum of the total sizes of the guys up to 100K? Okay, so we're going to say print sum of, okay, size for size in sizes dot values, because we don't care about the names, if size less than 100K. Is that right? I think it's less than or equal to, but I'm just going to go 1 on the end. So let's see what we get. Is that something? 1915606. Let's try to type that in. 1915606. Yay! That's the right answer. Okay, so let's do part 2. Part 2 is kind of like that, except we have a little more stringent criteria on the size. We probably can't do it in a single line. So we're still adding up the same paths. That's all the same. And then it says, okay, we have 7 and then 7 zeros, whatever that is, and then 3 and then 7 zeros. So we need the difference of those. We need like, okay, 7 is the total, and we need 7 minus 3, or 70 minus 30 million, or whatever it is. And then we have to see, like, what's the minimum guy we can delete to make that available. Like, if you had, you know, the way people experience this, you have games on your PS5 and you want to download something big, you got to delete something from your PS5, but you're trying to find like the minimum one that's going to do the job without having to delete multiple games or something. So let's take a look and see if we can do that. This number is so hard to keep. I don't even know what to call it. Is it 70 million? I'm just going to copy it. Okay. So I'm going to say, comment this out. And then make room so that it's in the middle of the screen. So what do we need? We need like size needed equals this minus this with a 3, and then whatever the heck that is. We need the total of our folders minus this. I think if I'm doing that right in my head. We need sizes of, okay, the very outer folder is just called slash. That's like if we scroll up to the top. Oh, I actually messed up. I think the for loop should start at 1 and not 0, but it doesn't matter. This is slash, and that 44274, that's like all the subfold. This is the big outer Russian doll that contains all the other ones. So I think what we want, whenever you have negatives, it's like so hard to flip it back and forth in your head, but I think we need that guy minus these. And then we need to find the minimum of the ones that could do that. So we need to find min of size for size in sizes dot values if size is greater than size needed. I think that's it. Let's see if that makes sense, or if that gives us anything at all. 502, 5657. Let's try that. Yes, that's the right answer. Okay. So I have to admit, today I totally cheated. I saw a video on somebody doing it, so this is not like me coming up with a brilliant solution. This is me remembering what I saw an hour ago. But it's really nice to like have that in your mind and then try to remember it. Like, I'm not looking at this on my second monitor. I'm doing this on a crappy Chromebook that doesn't have a second monitor. But the process of taking that and like dredging it up and trying to remember what the person did, and most of all trying to remember how you would do it. Like, he didn't put the accumulate size thing into a function. He just had some stuff and he had it in the opposite order, and he didn't use it as numeric, and he didn't use the slicing on these, but that's just sort of the way I was thinking of it. And he used a default dict, which actually would be better than a regular dict, but I didn't think of it until later. And since we only access it once, it's not like you have to use any boring default tricks 10 times. It's, you just have to do it once. And then the logic of this is actually not bad, because we use folders and subfolders all the time in real life, unless you're one of those kids who just has 1,000 untitled documents in Google Drive. Therefore, it's kind of normal to think of like, oh, the folder and all the ones inside of it. Even though in my mind, I don't always consider the subfolders as being related to the size. I guess they are if you're deleting it, as we are in part 2. So that was a great one, and I'm happy I did it, even though it wasn't pure, it wasn't blind, without help, but that's okay.